So this is the 4-step process. We're going to use a 4-step process and implement to the questions. Can we take a look at the next page together? I'm going to show you how I do the first example and you subsequently replicate it for me. Can we take a look at the first question? Work example number 1. So in the work example number 1, they tell me the hydrocarbon is 20 cubic cm, exploded with excess oxygen. Now there was a contraction. This contraction is the first contraction in the volume of 50 cubic cm. When the product was treated with excess potassium hydroxide, you see this is a base here. I am interested in the base because the base is to remove CO2. This is CO2. This is CO2. All volumes were measured at room temperature pressure. Determine the volume of a Z, or formula of a Z. What you need to do is write down step number 1. That is the hydrocarbon combustion process. CxHy gas is a gas, react with oxygen. And what does it give you? CO2 plus H2O. Now, keep in mind, CO2 is a gaseous, H2O is a liquid because it's room temperature. Now, there are times H2O can be a gas, so it depends on the conditions. Now, balance the equation. To balance the equation, you use a CHO technique, meaning that you balance your carbon first. The only way to balance your carbon is your hydrocarbon. X on the left, X on the right. How to balance your hydrogen? The next one, there's Y hydrogen on the left. You must have Y hydrogen on the right. So you put Y over 2 because Y over 2 times 2 will give you Y. After which, sum the total oxygen together. Sum the total oxygen will be 2x because this is x times 2, 2x. 2x plus Y over 2 times 1. So this is 2x plus Y over 2. Can I find out the value of oxygen? Definitely. This is 2x plus Y over 2 because I need this amount. But there's a 2. So you divide by 2. Because you divide by 2, you cancel away. You get this back. But I want to simplify it. So to simplify this equation, this will become x plus y over 4. That's how you can derive a solution. So right now, let me just delete this away and let me move this value in. And this will be 2x plus y over 4. Oh, x plus y over 4, sorry. Now here we go. How to balance this hydrocarbon combustion equation. So there's not really to memorize it. All you need to do is 10 seconds CH. So this is step 1. Now in step number 2, I mentioned to you, look for volume of a CO2 by the contraction of your hydroxide. So the volume of CO2, which is step number 2, is equals to 60 cubic cm. Because they tell me. Now step number 3 is a bit more difficult. This is finding volume of oxygen. So just now the formula doesn't make sense. Now I'm going to show you how you derive the formula from your very first step. The formula I'm talking about is this formula. So let me show you how you derive the formula. It can be derived. So first of all, you must remember that the contraction that you see here is the difference between the initial and the final. So all I need to do is take the initial volume minus away the final volume. It will give you the volume of 50. That is what we call the contraction. Initially it's high, it contracts to become lower. So what is the volume of the initial? Volume of initial is volume of hydrocarbon plus volume of oxygen because that is your initial gases. So volume of your oxygen, I need to classify. Got 2 types here. One oxygen is the one that is being used. The other oxygen is the one that is not used, the leftover. So I like to call it as a leftover. Remember, combustion is always burned in excess oxygen. There will always be leftover oxygen. So this is the one. Then followed by the final. The final is here. What do you have final? CO2. The volume of CO2. Now H2O is liquid. I'm not interested. But I have volume of oxygen left over. Remember, oxygen is always in excess. There will always be leftover. And this value will be equal to the first contraction. The first contraction is 50. What do you notice here? VO2, VO2, cancel out. Now, what I want to do is I want to make VO2 use. That is what you are interested in as the subject. So we're going to make VO2 use in the reaction as the subject. This will become 50, which is a first contraction. Let me put a note down. First contraction. Minus away your volume of your hydrocarbon plus volume of your CO2. Because I cancelled away these two. And if you check your formula on the first page, it's exactly the same. That's how you derive it. So there's not really need to memorize, but you must know how to derive it. Now I know the volume of my hydrocarbon. They tell me I need the value is how much? 20. So I'm just going to put a 20 here. I know the volume of my CO2, 60. Here we go. We can find the volume of oxygen gas. So the volume of oxygen gas used, this will become as, I think, 90. Here we go. We got two important values right now, 50 and 90. Now I'm going to translate this into the equation below here, which is right here. Let me just use a different color ink, maybe right here. I put down is 20 here. Then followed by your oxygen, the value is 90, and your CO2 is 60. Now this will be the value that we are interested in, because in volume, we can say volume of your gaseous is proportionate to number of moles. That is very important. Only apply to gaseous. Now I'm going to use mole ratio technique. Do you notice this is 1? This is one value, 1 over x. This is the mole ratio between your hydrocarbon and your CO2. Is equals to 20 over 60. And that's what I'm going to do right now. So this is 1 over x. 1 over x, because this is 1 over x here, equals to 20 over 60. Remember, mole and volume are the same in gaseous state. That's what exactly I'm doing right now. Equals to 20 over 60. Can I solve the value of x? Yes. X equals to 3. Rinse and repeat the procedure for your oxygen. This is 1. This is x plus y over 4. Can I do the same thing? So this is 1 over x plus y over 4. And is equals to, what's the value? 20 over 90. Because volume is proportional to your number of moles. So from here, this will be 20 over 90. Do I know the value of x? Yes. Substitute in. Solve the value of your y. You should get y equals to 6. And here we go. We finish solving it. Okay, so remember, the first step is to find your equation first. Second, find the CO2 based on the hydroxide. Find the volume of oxygen based on the formula I show you. You can derive it. Mole ratio. Then you find the answer. Now, what I want you to do is, can you repeat the same exact strategy that I show you here to the questions below? Most of the question in combustion is roughly about the same. Some of them may have some twists, but the fundamental.